Okay, we're into the next part of the tutorial, which is about the leveling procedure for the sample. So I'm going to go back into the software. And now, once you have prepared the drawing with the settings for the exposure that you want, you are ready to do the leveling procedure. So the first thing to do is to check that the UV laser is turned on. So this will be turned on by default when you initialize the system, so when you first open the software. But if you leave the software idle for about an hour, it will time out and it will turn off. So all you need to do is to just click again this button. And then the next thing is to hit the calibrate laser button. So the calibrate laser will calibrate the power of the laser and perform some other calibrations. So you have to click it and then you have to wait for the calibration to complete. So this is just a matter of waiting, and you will see the calibration complete message in the command log down here. I'm going to speed it up in the video so you don't have to wait as long. This will, oh, actually it's completed very, very quickly. Okay, so the laser calibration is completed, and now the next thing that we need to do is to click this prepare sample. So the next step is to make sure that the focal plane of the laser that is doing the exposure is level with the surface of the sample. And the way that this is done in this system is that you will select 3 points on the surface of the sample, which will usually be near 3 corners of the sample itself. And we then need to make sure that all these 3 points are in focus at the same time as we move across the sample. So I'm going to hit the prepare sample button. And this will only be available if you have calibrated the laser. So you need to perform the laser calibration first. So I'm going to select the 3 points, and you need to know where to put them, and where to put them depends on where the actuators are. So in this system, the actuators for the leveling of the sample are in the top left corner, the bottom left corner, and in the bottom right corner. So you want to select these 3 points so they are as close as possible to the actuators, but also within the area of your sample. So the area of my sample is the yellow box that's in the middle here. So I'm going to select 1 point in the top left corner near here. You want to stay a safe distance away from the edges, say at least a few millimeters, because the position of the sample may not be as accurate as it is in the CAD drawing. So I'm going to select 1 point on the top left down there. Now it's asking me to select the next point. So I'm going to go at the bottom left, somewhere here. And then I'm going to select another point near the bottom right, over here. So now I've got my 3 points selected, and the command window is prompting me to right-click to go onto the leveling procedure window. So if I right-click now, I'm going to get moved to this different interface. And what you need to do here is to click the Use Autofocus button, which will make this sort of bright reflection appear. You can just ignore this for now. I would normally increase the exposure by some amount, roughly like so. And then you want to go onto this sample nivellation tab. So this green box appears at the top of the camera view. So here we'll be following protocol. So I'm not going to go into the settings of each of these things, but what you want to do essentially is to move so what's happening inside the machine is that we want to get the sample to be in focus in 3 different points at the same time throughout the whole motion of the stage. So I'm now going to go on the Protolaser LDI navigation tab, and I'm going to select my points. So you see this is the working area of the instrument, and these 3 points are the 3 points that I selected earlier on in the CAD software. So I'm going to select point number 1. You see the red cross here is the current position of the stage. And now I'm going to select the first point, NP1. I'm going to click the right arrow to instruct the software to move the stage to the position of point number 1. So I'm going to move to point number 1. And as I click the arrow, this will gray out, and you will see that the stage is now running. So you just have to wait for the stage to reach NP1. So here we are now in position NP1. And now the proper way to do this, in general, if you're starting with a new sample, is to get all 3 actuators, the actuator A, B, and C, down to position 0, So I'm going to left click on this bar here and move the position of the stage to near 0. So it doesn't have to be exactly 0. And this is the position in micrometers of each of these actuators. And to move the actuator, you can either left click on a position on this bar, and this will go straight to that location. So if I left click, like so, the stage will move straight to that position that I clicked. Or the other option is that I can use a scroll wheel to actuate the motor. And you see that the position, the absolute position of the motor is gradually changing, and the further up I go on this bar, the faster this will go. So for the same amount of scrolling, it will move a lot faster if I'm near the top of the bar than if I'm near at the bottom of the bar. So to start with, in the alignment procedure, you will bring all three samples down, all three actuators down to near 0. And then you can use the focus bar, which is only can be used with the scroll wheel, to move all three actuators by the same amount, at the same rate, at the same time. So now I'm going to start lifting up all three actuators together, and I'm going to keep an eye on the camera, and what I'm looking for is for a bright spot to appear within the field of view of the camera and move towards the green box. So I'm going to start lifting this up using the scroll wheel, like so. And at some point, I will start to see this bright spot appearing. And the exact position when this happens will depend mostly on the thickness of the sample itself and how it's mounted inside the holder. So I'm going to bring this up, and you see now that there's this bright reflection appearing. And this is the pilot laser reflection coming up. So I'm going to keep going, and at some point it should go close to the green box. If I keep going, now I can keep going relatively slowly. And now you see that it's become a relatively nicely focused, bright white spot. So now I would usually drop down the exposure so it doesn't overexpose the camera of the system, and I can see exactly where the spot is. So the aim now is to use this focus adjustment bar to get the spot roughly in the center of the green box. And now we are going to move on to the next 2 points, NP2 and NP3, and make sure that the bright spot is within the green box for all three of these positions. So I'm going to now go to position NP2. So I'm going to hit the right arrow. Now the stage is running, so don't touch any of the motors until the stage is running. And this red dot at some point when the stage has finished moving will appear onto NP2. And as this happens, you will notice that the bright spot will start to drift in different places around the green box, or might even go outside the green box. And this is a normal thing if there is some tilt in the sample. And we will be correcting for that in the next step. Now the brightness has dropped off a bit, so I'm going to increase the exposure a little bit again. And now, for this step, we want to correct for the tilt of the sample. And to do this effectively, we have to make sure that we only now use one actuator and not all of three together. Because in the first spot for NP1, we were just getting the sample in focus with the laser. So for now, to correct for the tilt, we need to use one actuator at a time. And you want to be using the actuator that is closest to the point that you're looking at. So for point NP2, the closest actuator is the one that is labeled with A. So I'm going to go on the bar of actuator A, and I'm going to use the scroll wheel to adjust gradually the position of the bright spot. And I want to bring it back inside the green box. Okay, and roughly in the center of the green box over there. I'm going to do the same thing now with point number 3. So I'm going to move to NP3. Again, you notice that the bright spot is moving, and that's a completely normal thing. I have to wait for the stage to finish running. Now I'm in spot NP3, and I notice that the spot is pretty much as it was before, so I don't need to adjust the actuator B, and I can go back to point NP1 to check that after my correction in the tilt at point NP2, I'm still within the green box with the laser spot. And this is now moving towards NP1, and of course there is a little bit of drift. And as it moves back to point NP1, this is now in position, and I can adjust the position of actuator C to get the bright spot a little bit closer to the center, okay? So now I'm not going to go again through all of these myself, but I'm going to use the auto leveling procedure. So as long as the bright spot is within the green box for all three positions, you can use the auto leveling procedure. I'm going to drop off a little bit the exposure and hit the start auto leveling. And this is now started, and you see the auto leveling is processing right now, and this is going to move subsequently from one point to another and adjust the position of these points individually until it finds the optimal position for the leveling. So this process can usually take from about a minute to a few minutes, so I'm going to speed it up in the video to get it a bit quicker. Okay, so now the auto leveling has completed successfully. If this fails, you may have to rerun it, but usually it completes successfully. So now you don't need to worry about any of the other positions. You go back to the camera illumination tab and hit done. As you hit done, you'll be back onto the CAD software, and you're ready to send it to the laser. So you hit the send to laser button. This will show you the job processor. And here you can decide if you want the system to expose the fine tool first or the coarse tool first. In our case, it doesn't really make any difference because we don't have any fine tool features. So I can just leave it the fine tool first strategy, which is the default, but it's not going to make any difference in the processing. So an additional thing that you can do before you start is to check the preview box, which means that as I press the start button, it's not going to actually run the exposure, but it's going to preview what the exposure is going to look like. So I can click the preview button, hit start, and this will show me how the exposure is going to work. It's usually a very, very brief display because it will just run through the whole sequence very, very quickly. So you only have a few seconds to see it unless you have big structures. But if I rerun it, you see that it will expose according to the grid of the software. And when it's exposed to everything, it will finish. So I can now untick the preview checkbox and then can hit start. And this will now start exposing. So it will move the stage to the grid that is defined, and it will start exposing each grid cell individually. And you see the view of a single grid cell on the right-hand side. And there is very, very limited control over the order in which a certain block will be exposed. So there is an internal algorithm which calculates how the grid, in what order your structures will be exposed, and there's no way to change it. You can assign different structures to different blocks, and usually different blocks will be exposed in sequence, one after the other. But if you're really concerned about exposing some features before others, then you would need to do the exposure in multiple steps. So this is now running. It will give you an estimate for the remaining illumination time. This is usually not very accurate at the very beginning, but if you let it run for a few minutes, to maybe 10-15 minutes, then it will give you a relatively accurate estimate of the time that is left. And it will also keep count of the total time that has elapsed throughout the whole process. So now it's all just a matter of waiting for this to finish before we can move on to the next step.